Hi everyone, we're going to start now discuss the electric field of one charge at different charges. Let us start, right? Before we start explaining the electric field, every student has to be able to draw the electric field lines for each charge. Good? One electric field lines. Remember, electric field is a vector. Again, what? You have to be very careful. Vector quantity, right? Fix me.
It's okay, you got it. You can do physics.
Yes.
No, this doesn't matter.
Quantity. Okay? Vector quantity. Right? Now we good, right?
Okay.
Okay. Let us discuss the electric field line for positive charge, Q. How the electric line for has go out from what the charge, right?
So
Out of what?
in all directions.
One. And the number of line depends on the magnitude of the charge. Yani you're gonna have more electric field lines, right? When the charge becomes what? Increasing, right? Now here we're gonna have a negative charge. A negative what? Charge, and let us see how the electric field lines. That's wrong, right?
That's wrong.
Good job. Okay. Good job. You're following me, right? Good job.
I had
Then-
to learn it the hard way.
Here. But the lines will go where?
Towards-
N. Okay. Let us put two charges together, right? Negative and what?
Positive.
Negative and here what? And let us make believe they have the same quantity, because if they have two different quantities, we'll not be able to graph it. You can graph it for me?
Like, what do you mean graphic?
Okay. Graph the electric field lines.
The electric field. Like,
Line. Yes. Do different color. Use different color.
So like tell you which direction it points in?
Yes.
So this way, like this?
I need no. I need electric field
Towards which one?
or both of them together.
Okay, so you want two lines.
I don't know. Just try. Think.
It doesn't make sense to me.
Okay. I want to
So
make
wait,
it.
wait, okay, let me try. So if it's this guy on this one, then because this guy pushes, it's gonna go this way.
No. Okay. Let me just explain. Okay.
Yeah, 'cause I
Now,
don't know.
yes, okay. Now we're gonna go from this guy. Look, the first one, then the second one. You see,
I never even knew this was possible.
that's possible today, right?
Today.
Only today, not tomorrow.
Oh, okay, I get what you're saying.
And the same thing here. The line goes what? Look, but I'm gonna put the arrows like after what?
Which one?
After I finish.
Looks like
Then go. I'm sorry. Goes from where?
inside.
From
towards
yeah.
outside, inside.
Okay. Let me just use different color. Blue. Hold on. Go out. Right? Of the positive toward what? The negative. I want to give Ahmed, try. I'm going to erase it after you finish it. I want to give you two charges, but what? One negative and the other what? Negative. Use red color. Which one? The mode is, it's clearly for me, the mode number 8, right? I mean 3, right? Because the format of the verb that to be the most. And you set the median and find the average. Multiply, okay? 1, okay?
That is gonna look funny, right?
I'm no problem. Just try. We're gonna fix
It's
it.
gonna go this way.
Try. We're gonna fix it. Try. We're gonna fix it. How? The negative goes in the negative, not goes
Sorry,
out.
sorry.
Okay, let me just fix it. At least you tried, right?
Because I was thinking about them repelling each other.
Yes, they are, yes. But you have to be a little nicer. And then we make believe that all the charges are equal. But let us make some changes later on for some other charges.
So as you know, like this is confusing.
Look.
How do we think about this if it's not repelling or?
Look here, this guy, let us make believe. I'm trying to come to, look here, he doesn't know anything about this guy, right? This guy is walking. He doesn't know anything about this guy. He's walking. Oh my God, it's negative, right? Oh. Right? This guy, the same thing. He's walking, suddenly he found out this negative. Good?
So it's just add more base.
You tried, that's what I like in you, right? You tried, right? Right? Now let us put our R's, right?
It's gonna be toast.
If you don't put your R's, you're wrong. You have to understand, right? Right?
Yeah, it's kind of counterintuitive. Like it's,
This area, no electric field. No electric field. E is the electric field. E is what?
electric field.
Electric field. Now, as I said, we assume that we have the same magnitude of the charges because that you see this very nice, right? But if you have an example 2Q and 5Q, right? And both of them are positives, right? This positive and this positive. Look. You're gonna see something in here, a lot of lines, right? More electric field from this what? Guy, right? A lot of, but here guy, this small, it should be smaller. When you graph, you have to be very careful. You have to try to make number of what? Lines are less for which one? For this guy.
So how would it differ in calculation between?
We don't talk about calculation. We'll discuss the calculation, right? Let us just understand the concept of this. This goes out because both of them positive, right? Out. Okay. The median is smaller than the median. No, the median is bigger. The median is 2.7. Yes, the answer is B. Yes, that means it's equal, but which one is false, right? Incorrect. The median is 3. The median is greater, not smaller. That means it's false. And that's what you want. You get it? Okay. Now, after we learned how to draw the electric field lines for what different charges, right? Or same charges, positive or negative. And after we learned that the number of electric field lines what depends on or increasing when the charge increases, right? Let us see and back to the electric force. Why? What happened? Why the electric force happened? Why? And as example, we discussed, we have Q1 here, right? And suddenly if you put a Q2 somewhere here, either you get a repel or attractive force. Why? We just learned how to calculate, right? And how to find the force between what? Two charges. Now I'm going to tell you why that happened. Because when this guy come from nowhere to the Q1, the Q1 has what? Q1 has what? Electric field lines. He comes to the field of which one? Right? Don't come to my field. If you come to my field, I'm going to hit you with the force, right? these the electric field lines of which one? If Q1. Q2 comes to the electric field of what? Q1. Got hit. As you come close to me, I'm gonna hit you more. Which is true. When the distance decreases, the force increases, right? When you come close to me, as much you come closer to me, I'm gonna. What this mean? When you come close to the charge, the electric field of the Q1 will increases, and that will what? Push them away, right? That means the force depend on the electric field of the other charge. Then this guy Q1 has electric field at any point here. E1, 2, E what? 3.
So if we want
E1 is greater. E1 is greater than what?
2.
Greater than, which is because that they have a, if you go anywhere the high pressure, like the high voltage columns in the highway, there is a space, a place you cannot come close to it because the electric field of that pole is very high there. And when you come there, it's going to hit you with a very high force.
So whenever I want to find the electric field for this guy, I have to look at
No, for the force on Q2, if you want to force in Q2, we have to find the electric field of what? Q1. That means the force in Q, look at it, the force on Q2 comes from electric field of Q1. Q1, right? Then my objective is to calculate what? The electric field. My objective to the electric field of Q1. Then electric field equal K, which is the same constant, Q1 over what? R squared.
Okay.
Close to the Q, more electric field, right?
Okay.
More electric field.
So there is no reason for me to put Q2 in the equation.
No reason. And then we're getting to, and we're looking now for the what? Electric field of charges. The electric field itself, if you calculate it, that would create the force on Q2. And look here, if I move my hand around, as long as you are away from my hand, you're gonna not get affected. This is my electric what? Field. If you come close to me, exactly, this is my electric field. This is my two hands. If I turn around, anyone comes close to me, you're gonna get hit, right? With my electric field. The same thing for the charge. As you are far from her, you are safe. When you come close, you are what? Not safe. You are in trouble. Okay. We have some time to find the electric field. And electric field is what? Remember, electric field, vector what? Be careful. Vector. Example, quick example. Look. Q1 and we were Q2. The distance between them, look how the calculation becomes. 12 centimeter, right? We need the electric field at 4 centimeter from here, and what? Here's how much we have. 8. Find EA. E what?
So
Step 1. Hold on.
wait, I got a question.
Step 1.
This one.
Step 1. Step 1. Look, it's big or not big?
Big.
Assume there is a positive 1 charge at one column charge at A. If at the point, if he asks you to find the electric field at any point, always you assume there is what? A positive 1 charge. Will not affect my calculation, but will help me to find the direction of what? Right? Then,
So not negative, always.
yes. Then this A, this is my point A. This guy is 1. This is positive. And A, we said we have positive 1, right? Then 1 will have electric field here, goes to where? Then this E1, you follow me? Q2 at this point will run because this positive and that. Then this one, E2. Good? Then let us calculate the values. This is 2 microcoulomb and this is 3 microcoulomb. Good?
So whenever they don't give us the value of the charge, we just assume it's
No. I guess no. Always for electric field is not. Always for electric field. At the point where you want to find the electric field, you assume there is a positive 1 column charge. Okay? You never change it. That's not your choice. It's not a choice. When I want to find the electric field at any point, I assume there's a positive 1 charge.
okay.
Then E1 equal K Q1 over what? R squared. We know K is 9 times 10 to the 9. You have to back the old videos to see what? This one, right?
Times
Q1 how much?
Q1
One of them
is
2
times 10 to the negative 6
over
over R raised
8 times 10 to the negative 2 squared. God help me. Now here, my 10, 9 minus 6, 3 plus 4, 9 times 2, 18 over 64. What 18 over 64? What 18 over 64?
It's 0.28125.
Plus. Good. If he said right, you should do minus. I think so. I'm sorry. X plus 2. I'm not right. X plus 2. You have to write. X plus 2. Then you plug X.
I have 18 over 64 is
0.2.
8.28.
1, okay? Which is, right? 2.81. That's enough, right? Times 10 to the 6. In Newton per column, remember this is my unit. In Newton per what? Newton per column. E2,
6 plus 6.
E2, 9 times 10 to the 9, times 3 times 10 to the negative 6, over 4 times 10 to the negative 2 square. Equal how much? 27 over 16 times how much? No, I need that. 27 over 16.
1.68.
1 what?
1.68.
1.68. 1.69. This is round it to 1.69, right? 1.6 what? 9 times 10 to the what? 7, which is 116.9. Why I did this in Newton per column? Because the same, right? Now, two different, which one is bigger? E2, right? Then my final answer E2 minus what? E1, then to the left, right? E2 to the left? To the left, right? The negative x-axis. If you plug this 16.9 times 10 to the 6 minus,
So it's E2 is the negative y.
yes, 2.81 times 10 to the 6. Give me and write the answer. And to the left, negative x-axis. Okay. What should the 4%? Put 0.04x. 0.04x. The total. 0.04. Right? Total. Right? Equal how much? Then the calculator section, right? Divide by 140 and subtract it from 36. 10.6. With the same.
But I just wanted to check.
6 Newton per what? Left, right?
Exactly.
Negative x-axis.
So does that mean this value is negative as well?
Which one? This is not negative. This we don't have no negative and positive.
The direction.
Just the direction. The magnitude is right. This magnitude and the moves to where? To the left. Okay. Now we're gonna go